Hello everyone. In this video, we will go through the bond worksheet of the BA2 Plus calculator for bond valuation. To activate the bond worksheet, we press the second key and then the number 9 button. The bond worksheet is located as the second function over the button 9. The first variable is SDT, the settlement date or the selling date of the bond. We key in the date using the US date format, mm.ddyy. The next variable is CPN, the nominal coupon rate. And then the next one, RDT, the redemption date or the maturity date of the bond. We use the US date format to key in this variable. The next variable is the redemption value, RV. This value is entered as a percentage of the par value. If there's no information regarding the redemption value in the question, we assume that the bond is redeemed at par. So we set RV equals 100. And this is also the default in the calculator. The next two variables corresponds to the day count method and the coupon per year respectively. For the day count method, we can choose between ACT or 360. And in this video, we will use the ACT day count method. To swap between the two methods, we press the second key and then the button set. Set is the second function over the enter button. So by pressing the second key and then set, we can swap between the two methods. And then the next variable, coupon per year, 2Y or 1Y. This indicates the coupon payment frequency, either semi-annually or annually. And this variable also indicates the compounding frequency for the nominal coupon rate and the nominal market rate. So that is, this variable corresponds to the coupon payment frequency, the nominal coupon rate compounding frequency, as well as the nominal market rate compounding frequency. All these three frequencies must be the same in order to use the BA2 Plus calculator, the bond worksheet. So to swap between the coupon payment frequency, we press the second and then set to swap between 2Y and 1Y. The next variable is YLD, yield to redemption, or the nominal market rate. And then the next variable is PRI, the dollar price of the bond, or the market price of the bond. The last variable is auto-computed in the worksheet, the AI, the accrued interest. If the bond is sold on an interest payment date, then AI equals 0. Otherwise, AI will be greater than 0. The dollar price PRI, or the market price of the bond, this value computed in the calculator excludes the accrued interest. So if you need to get the purchase price of the bond, you need to add up the answer for PRI and AI to get the purchase price of the bond. So let's take a look at the first example. A $8,000 par value bond with a coupon rate of 8.35% compounded semi-annually with 12 years until maturity. If it is bought to yield 7.45% compounded semi-annually, what is the purchase price of the bond? Let's enter the variables. What is SDT, the settlement date or the selling date of the bond? There's no information in the question. So we simply set it as January the 1st in the year 2000. So we key in 1.0100 corresponds to January the 1st, year 2000. So enter this value, we can easily compute the RDT, the maturity date. CPN, the coupon rate, 8.35%. And then the maturity date, RDT, 12 years until maturity. So which is 12 years after the date we enter in SDT. So 12 years after January the 1st, year 2000 will be January the 1st, 2012. So we key in 1.0112 as RDT. RV here by default 100. Day count method, ACT. Coupon per year, or the compounding frequency for the market rate or the coupon rate. So compounded semi-annually. So this is 2Y. And then the market rate, YLD, 7.45%. And we need to get the PRI. Using the calculator, activate the bond worksheet by pressing second and then bond. Clear previous work if necessary by pressing second and then clear work. And then we can start to enter SDT 1.0100. Not to forget to press the enter key. And then next, CPN. Press the down arrow to get CPN. Enter 8.35. Press enter. And then the value for RDT, January the 1st, 1.01. And then the year 2012, so we key in 112. And then enter. Next, the value for RV. It is already 100 in the calculator, or you can enter this again by pressing 100 and then enter. Next is the day count method. It is already ACT. We don't need to change anything. And then the coupon per year, 2Y. Again, in the calculator, already 2Y. We don't need to change anything as well. And then key in YLD. YLD is 7.45. So key in 7.45 and then press enter. And then press the down arrow key, we get PRI. We need to compute this value. So we press CPT. And we get the number 107.05845. And then we press the down arrow key again to get the value for AI. This is automatically calculated. So the purchase price of the bond is the total of the PRI and the AI. And here AI equals 0. So we can just simply work with the PRI. The answer obtained from the calculator at this moment is not the final answer. The value for PRI and AI is expressed as per $100 of par value. So we need to do the conversion. In this example, we have a $8,000 par value bond. So we need to divide the value of the PRI by 100 and then times the face value of the bond, which is 8,000. So we take the PRI 107 1.0584 divided by 100 and then multiply by 8,000. And then we get the purchase price of the bond, $8,564.68. Let's take a look at the second example. A $2,000 per value 10-year bond with coupons at 6.25% payable annually. The bond is bought to yield 7.5% compounded annually. What is the purchase price of the bond? Key in the variable, SDT, the settlement date. No information from the question, so we simply set January the 1st in the year 2000. CPN, the coupon rate, 6.25%. And then RDT, the maturity date, 10-year bond. So 10 years after January the 1st in the year 2000 is January the 1st, 2010. So we key in 1.0110 for the variable RDT. And then the redemption value, by default, 100. We use the ACT day count method. The coupons are payable annually. So coupon per year is 1Y. And then YLD, the nominal market rate, 7.5%. And we need to get the PRI. Using the calculator, clear all the work if necessary after activating the bond worksheet. And then key in SDT 1.0100 and then enter. And next CPN 6.25, enter. RDT January the 1st, 2010, 1.0110, enter. And then the value for RV, 100. It is already 100, so I don't change anything. Day count method, ACT. Coupon per year, 1Y. So I need to change from 2Y to 1Y by pressing second and then set to 1Y. And then YLD 7.5. 7.5, enter. And then we can compute the value of PRI. Press the CPT button and we get the number 91.42. And press the down arrow again to get the auto computed value AI. And here AI equals 0. So the purchase price is simply the market price PRI in this example. Okay, do the conversion. The PRI and AI is expressed as per $100 of par value. So to get the actual purchase price, we convert the PRI 91.41 divided by 100 and then multiply by the face value 2000. And we get the purchase price, $1,828.40. The next example. $100,000 par value bond with a coupon rate of 5.05% compound semi-annually was issued on January the 15th, 2008, with 20 years until maturity. What was its purchase price on July the 15th, 2015, when the market yields were 3.95% compounded semi-annually? Now we have the selling date, July the 15th, 2015. So we key in 7.1515 as SDT. CPN, the coupon rate 5.05. RDT is the maturity date of the bond. The bond was issued on January the 15th, 2008, with 20 years until maturity. So the bond matured on January the 15th in the year 2028. So we key in 1.1528 as RDT. RV by default 100, day count method ACT, coupon payment frequency, or the compounding frequency for the coupon rate or the market rate, semi-annually. So this is 2Y. And then the market rate, 3.95%. Compute the PRI. Key the variables into the calculator. SDT, 7.1515, plus enter. And then CPN, 5.05, enter. RDT, 1.1528, enter. RV is already 100, so press the down arrow to get the day count method, ACT, and then press the down arrow again. We need 2Y, so we need to change the setting by pressing second and then the set. YLD 3.95, and then press enter. And then press the down arrow key, we get to PRI. We need to compute this. So by pressing CPT, we get the number. And then press the down arrow key again to get the auto-computed result AI, the accrued interest. AI equals 0. And you can justify this from the question. The bond was issued on January the 15th, and the coupon is paid semi-annually. So the coupon is paid on January the 15th and July the 15th every year until maturity. And the first coupon payment is on July the 15th, 2008. The settlement date or the selling date of the bond is July the 15th, 2015, which is on the interest payment date. So the accrued interests are all paid out. So AI equals 0. So we get PRI equals 110 and AI equals 0. So the purchase price of the bond, which equals PRI plus AI, and AI equals 0. So the purchase price only depends on the value of the PRI. Not to forget to do the conversion. So we take the PRI, the value of the PRI divided by 100 and then multiply by the par value 100,000. And then we get the purchase price of the bond. Let's take a look at the next example. A $60,000 par value bond with a coupon rate of 5.25% compounded semi-annually was issued on December the 1st, 2014, with 25 years until maturity. What was its market price on April the 17th, 2023, when the market yields were 4.15% compounded semi-annually? Here, the question asks about the market price, which is the variable PRI in the bond worksheet. And you can see that the bond is sold on a non-interest payment date. The coupon payments are paid on December the 1st and June the 1st every year until maturity. And now the bond is sold on April the 17th, which is not the coupon payment date. And therefore, we should expect that the value for AI should be greater than 0. And now in the question, we are asked about the market price, the PRI. Let's get the variables. The settlement date, April the 17th, 2023. So we key in 4.1723 as SDT. Coupon rate 5.25. Redemption date. The bond was issued on December the 1st, 2014, with 25 years until maturity. So 25 years after December the 1st, 2014 is December the 1st, 2039. So we key in 12.0139 as RDT. RV by default 100. Day count method ACT. Coupon rate compounded semi-annually. So we have 2Y for the coupon per year. YLD 4.15. And we can compute the PRI, the market price. Okay, get the bond worksheet from the calculator and we key in the variables. SDT 4.1723. And then CPN 5.25. RDT 12.0139. RV is 100. Day count method ACT. Coupon per payment, coupon per year, 2Y. YLD 4.15. And then we can get the value for PRI by pressing the CPT button. PRI equals 113.11. And then we get AI different from 0, 1.9759. To get the market price, we use the value of PRI and then divided by 100 and multiply by the par value 60,000. So the market price of the bond is $67,866.25. This is not the purchase price of the bond. This is only the market price. Okay, so to get the cash price or the purchase price of the bond, we need to compute the accrued interest, which corresponds to the value of AI. So do the conversion as for PRI. So the accrued interest for the bond is the value of AI 1.97 divided by 100 and then multiply by the face value 60,000. So the accrued interest is $1,185.58. So what is the purchase price or the cash price of the bond? So this is the total of the market price, the $67,000, and the accrued interest. So sum these two values, and we get the purchase price or the cash price of the bond, which is $69,051.83. That's it for today's video. Thank you for watching and see you in the next video.